All right. So a big round of applause for the last keynote of the event. I don't need to do any introduction. Everybody knows who you are. All right, go. Thank you.
Cool. So thanks for having me. Apologies in advance. I'm still jet lagged. Flying over here is never easy. All right, so today I called this Mastering Duct Tape. This is kind of a way for me to rant about a lot of things I hate. And I was pretty excited to put this together because I don't really give technical talks anymore. And then I realized all the things I wanted to talk about took up more time than we really had today, so we'll see how this goes. So if you don't know who I am, I'm the creator of Sentry. How many of you know what Sentry is? Cool. So a few of you, we do air tracking, crash reporting. It's open source. It's one of the largest open source, I guess, services out there now. San Francisco company. We look like all the San Francisco companies, but built on Python, been around for a long time. I don't really write code anymore. At least I don't get paid to write code anymore. But I would still say I have my ear to the ground, and I have a bunch of side projects here and there. So first, let me give you a little bit of condensed background on me, why you should trust me in this. So I have a lot of experience writing all kinds of applications, about 15 years of experience at this point, give or take. I'm self-taught, but I've been doing Python since, I don't know, early Django days, 0.95 or something like that. Probably the first thing you'd recognize I worked with was a company called Discuss, which doesn't really exist anymore. Still on some websites, it's a little comment widget. I joined and helped them scale that out to 1 billion page views, which was a lot at the time. And that's a page view is really like it renders that widget on like a CNN.com kind of site. So it eventually became a lot of caching CDN problems, but enough scale to get your kind of get your feet wet. And then more recently, I moved to Dropbox, and I like to say I over-engineered a very complex system. We had a problem with testing at Dropbox, and I'll talk a little bit about that today. Not nearly in enough detail to describe this, but I built a several thousand node system just to run distributed tests. That is like literally to run unit tests in Python because they were so slow. And I also built Sentry, and I bootstrapped Sentry from the ground up. We raised a lot of money at this point, but started it very lean, and a lot of those principles are what I'm going to talk about today. And I type really fast. It might be important to our ability to get some of this done. Cool. So let's see. Let's jump into it. So what do I mean by duct tape? I assume duct tape is universal, and everybody knows what duct tape is. But I mean specifically when we get into software, but it's such a commonality in like real life. So I do a lot of like backpacking, camping, climbing, and duct tape's kind of one of those fix anything solutions. So I've personally used it to patch like holes in tents. I've used it as Band-Aids. I've used it as like grip on things. It's something you always carry with you because you can use it to apply to any problem. Like there used to be this television show called MacGyver. I don't know if anybody's ever seen that or if that was an American thing, but I feel like MacGyver would fix anything with anything, and duct tape would be one of those practical solutions. So this is like me just searching on the internet, like what have people done with duct tape? Some of this is the obvious stuff. Some of it's like, I don't know, duct taping the hood of their car to keep it closed. I guess that works. Very cheap solution, very pragmatic solution to solve a problem. Not perfect, but gets the job done. And that's where we're going with this. So when we talk about duct tape and software, and this is sort of where I started this thought process for the talk today. I'm like, okay, there's all these things that are pragmatic solutions to problems. And we often don't take the easy way out, and duct tape's the easy way out. We take the very complicated way, which I'm going to actually, I saw a couple talks today. I'm probably going to say the opposite of what everybody else said in those talks, so bear with me. You can trust me or not trust me here, but you know, a lot of these things should reflect experiences you've had. Some of them are a little bit specialized, like when you look at companies like Dropbox or Facebook, they do things very differently than other companies, but the same problems roughly apply. I found this quote, which I really like. If you can't fix it with duct tape, you're not using enough duct tape. I think that's very, very true. There's always a more simplistic solution to the problem that you're going after. So, you know, again, I said I started this talk. I started writing. It's actually the first technical talk I've given in, I don't know, 3 or 4 years. I usually talk about business or open source or something. And I was excited because I'd been throwing around this idea for a long time. I'm like, I want to go like get rid of all these myths and point out how easy some of these problems are at scale. And I started making this list of all the things that are like sort of these duct tape problems. And then when I started going through the slides, I realized I only had time for a couple rough things. So one is databases. Everybody has a database. It's like the most common thing. And then two, I've sort of jammed in everything else, but it's mostly like architectures. So there's not going to be a line of Python in here, though there are a bunch of libraries and examples I'll point out that are Python, but this applies to any kind of software. And then I'll leave time at the end, questions, ask me anything you want, whether it's about this, about Sentry, I don't know, you name it. I'll also be around afterwards. So databases. So how many of you use a SQL database in your job or in your side projects? So I would hope most everyone. If you're fortunate to not need a database, I don't know what you're doing, but you are very lucky. They're actually very nice to work with. They've gotten better over the years. They're still hard to scale. And we'll talk a little bit about that. So this is one of my favorite topics, and I'm not going to be able to do it justice because I could fill a whole like hour-long talk just about databases and optimization and things like that. But we'll see what we can get out of this. So first, let's just say we have a blog because it seems to be everybody's app. They all look the same. A blog has a very simplistic schema. You've got posts, which are your blog entries. You've probably got users, and then you've got comments on those posts. And comments are what we want to focus on here. So we're going to talk about sort of over-engineering and optimizations and things, and comments are going to be the one that have the most entries. And this is purely coincidence that I worked at Discuss, and Discuss was about comments. This just happens to be a very common model. So what does the schema look like for that? Again, I've simplified this, but imagine you have the ID, which is usually auto-incrementing, straightforward. It's a number. You have the post ID, which references the post in the other table, which is a number, straightforward. Display name, this is probably whatever you type in, like I'm David Cramer. The body, which is like, hey, here's my comment, and then you have the date when it's posted, right? Just a little bit of metadata. Now, you all probably know how to write this query, but to get comments, it probably looks something like this. You're selecting whatever data you need, which in this case is pretty much every field, and we're filtering it down by the post, and then we're sorting it. So imagine we've got a lot of comments here, but more importantly, we've noticed this query is slow. So what do we do in this case? And this is generically slow. This is what I would do at the scale of Sentry, which we operate some of the largest Postgres databases that I'm aware of now, or Dropbox, kind of anywhere. It all actually works exactly the same. So the first thing everybody does, or should do, is look at the indexes. It's usually very easy to spot a problem right off the bat. Indexes, if you're not super familiar with optimizing them, it's this trade-off between write and read performance. So the more indexes you have, assuming you have memory, the faster reads will be, but writes are going to be slower. The higher cardinality of the index, the slower they're going to be. That means like the more unique values in an index, just because of the way the common ones are structured. But generally they affect like the disk, and they're based on the amount of memory you have available. The second kind of thing you look at if you have like a performance issue in something like this query is like, is the table big? I think the size on disk is actually more important to the row count in all practical purposes. So we'll say big is like, say it's a 10 terabyte table. And then like, is the server on fire, like classic things. But honestly, like this you rarely ever have to get to. You notice a query is not well indexed because the server's on fire and it's using a lot of CPU, usually because it's sorting or doing something else, or it's using a lot of disk. But that'll be a symptom. So if you're all familiar with indexes, and especially if you use something like Django, it's going to create an index that looks like this. It's going to say, okay, I have this foreign key to the post table. Let's create an index on post ID. And this is actually pretty good. This actually breaks down in one case, and that's the most common case to optimize on. So in this case, it can actually pull all the post references from memory because we're filtering on post ID, but it still has to resort those, which means it has to pull them all off disk to resort them. So the index actually doesn't do a lot here. And this is fine if you have like 100 rows that are connected to that post ID, so say 100 comments, but if you go to like a giant comment thread or a big Reddit thread and imagine there's like thousands of those comments, and then there's many of those other threads that have thousands of comments, this actually becomes a very serious performance bottleneck. So one of the first things you might do here is optimize this to add, call this a composite index, to add the date in it. And hopefully this isn't new to anybody. If this is, there's some very simplistic, clever stuff you need to understand about databases. So almost all indexes are going to be B trees in practical use, and they optimize from left to right. So in this case, the order of these fields at the bottom matters. The reason it matters is because I can actually use the index from left to right. So if I get rid of this order clause, it'll still use this index because post ID is the field that we're selecting in there, and it's the only field. Now, when I add the ordered entity here, because it's a B tree, and I'm not going to go into the data structure of a B tree, but it actually ends up being ordered anyways. So it's very fast if you store it like this. Now, obviously, there's a trade-off of write throughput, right? But structuring indexes like this, and more specifically when you do this, dropping this index, you don't need both, is almost all you ever have to do. And it's such a common case that something's slow and you just go fix it like this. And it actually surprises me how many people don't understand the basics of this. Like if you're working with databases, like this is the greatest tool you have. And if you're using like Postgres, you can actually make even, say even more clever indexes, but there's still caveats there. Like we actually learned recently that Sentry's databases are so large that the indexes don't really function anymore. Turns out no databases work at scale. But we're gonna ignore that caveat and still go with this. You know, what do we do if, in that kind of situation from there? Well, like, there's a lot of optimizations. We'll talk about them in a minute, but it's actually much more complicated than this usually, right? I give you a really, really simple example of a comments table. That one probably optimizes very easily. But say in the real world, it probably looks more like this. So especially with comments, you've got trolls on the internet. They might go and post somewhere like, I love Trump, and then they're gonna go edit it and be like, no, boo Trump, I love Obama. You wanna know about that history because you wanna moderate it, right? So you probably need a sort of revision for every edit of a comment. You probably also have some kind of likes, like thumbs up, thumbs down or something. Maybe that's for showing the best comments, maybe for it's helping moderate, but it actually makes these queries much more complex, right? So now we'll go to the more advanced version, which is more practical in all sense of this. So this is actually very annoying to deal with in a database. This is how I would structure it. We didn't actually do anything like this at Discuss, so it didn't really matter there, but you know, we swapped out all of the core comment data and we put that in the revisions table. And we've added 2 foreign keys. So we assume all users are registered or we stick them in the users table somehow. And we point to the latest revision ID, which is probably the most current version of the comment. It unfortunately changes our query pretty drastically here. So we have to join on 2 other relations because we need the body from the revisions table and then we need the display name from the users table. This is actually much, much harder to optimize. And again, I could give a much longer talk and explain how to optimize this, but it's too complicated for a few slides. But the way to think about optimizing queries is you want to limit the number of rows you can select on the first pass. So you want to get the smallest number of rows that the index will cover, and usually the query planner will try to do that. But in this case, you have to ask yourself, well, what it would do right now is it would select all of the comments that have the post ID and date posted index. But if that's like tens of thousands, it's still going to have to join in memory on these other 2 tables and potentially sort those and stuff. So that won't be super fast. There's ways around that. There's lots of clever ways. I'm happy to talk about that afterwards if you're interested. But let's just know we've got something that's slow and hard to deal with right now. So it's fully indexed. Say we've solved that. It's still going to be slow. What do you think we do next? Like anybody? We could denormalize. That'll be complicated in its own right. So partitioning or sharding, there's lots of words for this. This is the next step, I would say. And this is effectively saying I can't fit everything on the one machine. It's too slow. So let's add another machine so we can like effectively double the resources, right? Double the CPU, double the memory. Vertical partitioning is the easiest version of this because it's basically just move one table somewhere else. It's still not easy, but it's the easiest, right? There's some magical things that will do this for you. Like there's one lesson I've learned in my career, don't use any fancy technology, it never works. You know, we've repeated learning this lesson at Sentry once we started trying to use more fancy technology. Turns out going back to the primitives is the only thing that functions. But when we do that, so say we're doing the vertical partitions, we actually have to make some changes, right? So we'll talk about these in a minute, but there's a couple things that have to change here. The author and the post ID, they're going to live on a different database server, so they can no longer be foreign keys. And that actually has a pretty serious consequence. They're still integers. We can still look them up sort of in the same way. We just can't look them up in one query, at least not without some magic, which, again, we're going to ignore those kinds of situations. So what do you do to implement vertical partitioning? Well, first you're going to have to change that database, change those foreign keys. That's usually somewhat cheap on modern databases. You can run an alter in production. We still run alters in production at Sentry. Like you can commit a database migration to Sentry, deploy it in real time. Bigger companies have clever solutions to do similar things. So that's still fine. The next part is where it gets really painful. So what we did, and this is like real life from Sentry from a long time ago. So we'd always just replicate the database. So that means you need another server that's big enough to hold the whole database. And then we'd go over, we'd figure out the cutover, we'd update the application logic and everything. And then you have to be very clever, or you have to take downtime to actually switch databases, because what you eventually get is you get sort of your primary database and then your failover database, and they both look like replicas right now. And what you need to do is make both of those primaries, one serving the new tables, one serving the old tables. And the only way to do that is to stop writing to the primary database, so you can actually promote the other primary. And so for us, that's pretty easy because we had a lot of jobs that work asynchronously, right? So a lot of Sentry is like, send us an error report, we process it in the background really fast. So all we have to do is say, well, we're going to stop processing for a few seconds, flip it over, okay, we're live on the new database. And then you go up and you truncate the tables, and there's a bunch of cleanup and stuff. But it's still very complicated, and that's what I'm trying to illustrate here. And more importantly, you probably forget about some things when you're doing it. I know we always have, and I'd like to think we're pretty good at this. You often forget about some code referencing it. If you use Django or SQL Alchemy, you're defining these relationships. You might define one wrong or access an attribute that doesn't exist. And if you're one of those rare companies that actually has test coverage for every line of code, congratulations. I've seen that to be very rare in the real world. So we're likely missing some code. It's still broken. Another big thing that we're immediately going to see is maybe we can delete posts, or they go orphaned, or it's not caught up, and all of a sudden we have comments that don't actually have a post corresponding to another table, which actually leads to future problems, because now we'll end up with orphaned comments. So you actually need to handle both of these cases, and this is something you often don't think about ahead of time, because if you had foreign keys still, these relationships would be enforced, cascade deletes might still exist, so you have to re-implement a lot of solutions for these problems. So like in Sentry, we've got a ton of code just dedicated to like, how do I delete data like in like bulk ways across many databases. And it gets very, very complex. Still solvable though, if you like just reason through it. Okay, but let's say we can't scale with vertical partitioning. So we'll skip the question in this case, but we're gonna partition again. So this is what people commonly refer to as sharding. Usually people look at vertical partitioning and they're like, oh, that's not cool, that's too easy, like we have to scale more than that, like future-proof things, right? So let's say we're future-proofing right now. So comments are a big issue here, right? So let's just say, okay, we can separate by year. So we've got a database for every single year, and we're like, that's great. That means, every year we can store all the comments, we'll be fine, we can scale forever. Now there's a problem with this. Well, one, it's gonna be a massive nightmare to implement. But two, like, I'm going to assume you're going to have 100 times the number of comments in 2019 as you did in 2018, and 100 times in 2020 as you did in 2019. So then what do? Well, you break it down even more. So maybe you partition by month. And you can get where this is going. Now, this isn't even covering how you query this data, and there's other ways to partition. All of them have their own problems. But it's very, very hard is what I'm trying to illustrate. And then even more importantly, you're probably like, oh yeah, the posts. We need a future-proof post too, so let's shard the posts at the same time. And we actually went through all of this at Discuss. It was a massive nightmare. I think we have a little bit of this at Sentry, but Sentry's mostly run on giant single database servers still, and some other software. So this is going to be very hard and still doesn't necessarily solve your problem right now. Well, then what do? Do you bring in MongoDB? If you know me, you'll know I love MongoDB. I'm not serious when I say that. Cassandra, like other database technology, we're actually sort of building our own right now. I don't recommend you do that. To be concise, you don't need to do any of that. It's just all to illustrate like, why are we wasting time on this? Literally all you had to do was add more memory to the server. If you use a cloud provider, it's really, really easy. Like we scale up databases in real time on GCP now. Like with just like add a bigger disk, done. We don't have to do anything. It's copy on write, right? Like all we had to do is add memory. You're gonna have to rewrite things every 2 years anyways, but like almost every single time in the history of Sentry, all we've had to do is add memory. Now there's a scale where this doesn't work. Most of us will be lucky to reach that scale. I think there's very, very few companies out there that achieve it. But like, it's such a simple thing. It might seem great to go like write all these fancy systems, but they're not fun to maintain. So Sentry's about 10 years old. And I built the SaaS service for it 6 or 7 years ago, and it was a side project I did in my spare time, ran the servers. Every 6 months, I upgraded the database server to double the memory, scaled still today. I don't know how much memory is in each of our database servers, and there's certainly a lot more of them. We do vertically partition things, but it's gotten us very, very far. And this is like several orders of magnitude in scale. So the lesson is like, just take the easy way out. This is what I mean by duct tape. Like, just get the job done and move on to the next thing. Okay. So databases, again, there's a lot more I could talk about there. If you're interested in like talking like database scale optimization, whatever, grab me after, or ask a simple version of a question at the end. But let's move on to the second act. Services and things, or everything else, I would like to call it. This is my favorite, and I actually thought about restructuring this talk just around this, because I wouldn't say I'm a hater, but I don't really like new ideas, especially when they're built on old ideas and just renamed. I was watching Nicholas talk the other day where he's talking about observability, and observability is literally just a new word for monitoring. It's the same thing. We love making these things up, right? So let's talk about architecture. So this is a monolith architecture. You're probably all familiar with this, monorepo. How many of you actually still operate under probably one giant repository? Maybe it's 2 giant repositories. We certainly do. Every major company in the world does, for what it's worth. Usually, even at Sentry, we have a few services now, but most of our stuff lives in one repo, and we're moving more towards that. And this was an interesting exercise I had at Dropbox, because before I joined Dropbox, I was a big open source proponent, and open source is like you have a dependency over here and a dependency over here, and then you have NPM, and nobody knows what's going on, right? Well, because monoliths aren't cool anymore, or they slow us down or something, pick your reason, we need to move towards that world of dependencies and services and, the famous service-oriented architecture. And I would expect most of you are familiar with this, but a service-oriented architecture is where you try to split up some concerns. So maybe a very common version of this is if you try to log into a Microsoft account, you're going to hit like the Microsoft login service and then get redirected back to whatever Microsoft service you're using. That's like a real proper service implementation, like where it's got this big bulky auth thing that handles everything auth and manages the rest of the system. But so is outdated. Like, it's also not cool anymore. So we renamed it, and now we call it microservices. This is my favorite topic. So people ask us about microservices all the time, because the nature of Sentry is like we're collecting errors, which are like application data, right? And it's like, oh, could we trace the error between services? And I'm like, you don't need to. You probably only have 3 services anyways. But microservices are like a more intense version of this idea of a service-oriented architecture. I think the extreme of this is what everybody describes as serverless, which is a really funny word I don't quite understand. I think it's also marketing. But I describe serverless as like I have a function that runs in the cloud somewhere. And that's like every single service is a function, and I have no idea how any business would operate with that, frankly. It seems impossible to maintain. I assume you put them all in one giant repo and not separate repos at that point. But the idea of microservices is that like every service is contained, it does like this one thing well, right? So let's say we've decided that this is the thing for us. Like, how are we going to get to microservices? Well, first, this is very important to illustrate, because whenever somebody talks about microservices, they almost always mean one repository per service. This is the whole reason to come up with it, and this is going to be important as we go forward. So just think of it that way. Even if this might not be true in your organization, we're going to work with this. So what do we do when we're moving to a SOA? So first, we're going to build a service framework. Because Python's not really cool anymore, we're going to build it in Scala. Seems like a good exercise to introduce Scala in our company, so we're going to build a Scala service framework. And because now it's in Scala, or maybe we can support every language, but we'll build that framework in other languages too. We're going to go take that old crufty code that Joe wrote. It doesn't work here anymore. We didn't really like him anyways. We're going to go rewrite that code because it's old. And then we're done. We've got like this great microservices architecture now, right? I don't know if any of you have actually tried to transition to services. This is obvious. I'm being a little bit of a troll here. This is not how it goes down. To some degree, this is actually halfway how it goes down, but it does involve you probably build a service framework. It might be lightweight. You might just say, we're going to take Flask, and we're going to build a little bit on top of it for a service mesh. But then you end up adopting a lot of new technology. So one, almost every real services platform I've ever seen is based on PubSub. So it probably uses something like Kafka to communicate. And Kafka is a pretty heavy infrastructure tool. If you're not already using it, it's because you don't really have a good reason to use it. And this is not a good reason to use it. It's a lot harder to manage than something like a SQL database, or some people would trade out something like RabbitMQ or Redis as a queue for Kafka, similar properties. But they'll use this to set up like I'm an upstream service, I'm going to publish my changes, and downstream services can subscribe to those changes. And so it becomes more autonomous. It's not a bad idea, it's just really complicated. So anyways, you probably end up setting up something there. Then, because the microservice needs to own a chunk of its data, you probably are going to want to break up your database. We just talked about how awful that is. So good luck with that one. Now, if we're smart, we'll write one new service in this. We'll take one smaller problem or one new problem or one serious problem that we know we need to rewrite anyways, and we'll launch that. And most people, I think, would do that. You might have some people that are like, okay, and then we're going to rewrite that one and that one and that one and that one, but we won't worry about that right now. Then you're going to quickly find that your automated testing no longer works because it doesn't support all these repos, or it doesn't test anything remotely like production. You're going to find that the deployment tool needs rewritten, and on and on and on and on and on. It's like an endless list of problems here. So if we take a step back and say, okay, what was our goal with microservices? Ignoring, I think most of us are reasonable human beings. We're not just doing it to be trendy. We actually think there's value in there. So let's talk about what I think the common goals are of that. So we want to speed up the build process or the test process. This is almost every single time I hear somebody, it's like, if we just split this out in its own repository, it can run as a service, and then the build will be really fast because we don't have to run these other tests. It's so common. I don't disagree, but that's the goal. That's not the solution, right? Better ownership is a big deal, right? I want the API team to be able to fully own the API code. That's fair. That's a good goal. Reliability. So often almost required in microservices, you need to some degree forwards and backwards compatible API bindings. This is also a huge engineering challenge. Good luck implementing protobufs or something equally awful. But you want those API contracts and API version. And you can often reduce complexity. I'll give it, this is fair. You almost always get reduced complexity with a single service, except when you add 100 other services. But it's a good goal. And then you often need to transition away from some legacy, harder to maintain systems. And I'll say this is a real goal, not just we want to write code for fun. Sometimes there's a real reason to transition away. So then the question is, do we really need a services-oriented architecture to achieve that? I don't really think so. So I'm going to introduce the duct tape-oriented architecture. So I got this name from somebody in Sentry, the microlift. I think they use this at Heroku. So you can actually achieve all of this in one giant repository, which might be one giant service. And Sentry actually, it's really hard to go into the code examples here. I'm happy to talk and point it out, but Sentry actually has a bunch of services baked into it. I don't know the last guy's name that was up here, or maybe the guy before, but he was talking about interfaces and facades and stuff. And we actually do a little bit of that, where we have a service abstraction inside the process. So for the cache, and if you use Django, you're familiar with this. If you have the cache, you have memcache, or you have in-memory cache, or dummy cache, or Redis cache. That's effectively a service. Which service are you talking to? It's just an implementation detail, right? So we actually have a ton of those inside of Sentry's code base for all of our different core systems. We often only implement one version of that service, but it's still isolated. It has an API contract. And so that's what I mean by this microlift. It's all running in the same code base and hypothetically the same process, but we'll talk about that. And then every so often, you're still going to end up with a dangling service. And what I've seen at Dropbox, and I know Facebook is similar, and a lot of other companies, is you actually end up with one repository per language, usually. And that's because tooling is a lot easier, testing is a lot easier, build systems are a lot easier. And this was the pattern we actually pushed at Dropbox. I sort of took away all my opinions, and I'm like, you know what, you're right, we should be doing a monolith. It's the better way to solve these problems. There's also other more political reasons they do monoliths. It's compliance and scanning and stuff. But it actually works really, really well. So we're actually moving Sentry more towards a monolith. But again, more of a monolith per language, or where it actually makes sense. You can also do find and replace in a monolith. Even though you can't necessarily interoperate those services at the same time, there's some asterisks there. But it actually makes it easier to roll out changes. So instead of doing 5 pull requests to change 5 services, you just put up one that's compatible both ways, right? So code review is easier. And that's what I'm going to talk about now. So imagine this world. Just bear with me. We're going to solve all the problems, assuming I think I have enough time to solve them all. But the most important thing that we have to control these problems is the change control process. So if you're any company that has to deal with, I guess European, it's ISO compliance, but SOC 2, if you have any compliance in your organization at all, your change control process almost certainly looks like this. Like code review is required, tests being green are required, it goes through a build process, things like this. If you're not, you should adopt this. It works really well. Peer review is kind of a pain in the butt, but like, let's look at what we have here, because I think this is the thing we control the most. And we actually say at Sentry, even though we do monitoring effectively right now, we say our only goal is to make it easier to ship code, to get to the end goal, right? And there's a lot of people that help with this, like GitHub. I'll probably use Travis CI. There's a lot of tools in this space. But there's kind of a split between the categories here. So on the left side, like the code and peer review, these are very like human problems. So I can't control how you write code or you write code. I can't control how you review my code or if you're going to review it today or tomorrow. I can try to harass you and maybe you'll get it done. But they're very human problems. They're actually pretty hard to optimize. I still haven't figured out how. People still struggle to code review other people's code at Sentry, even though it's mandatory. So those are problems I'm going to set to the side because I don't have answers. On the other half, we can actually automate a lot of this, right? And in most companies, it is automated. Now, some bigger companies are more historic companies or ones with different release processes. They might have humans in here, so maybe the test phase is actually a lot of manual QA. Even smaller companies might have a little bit of that, but they're largely automated, right? Sometimes these also run in parallel. So for example, at Sentry, we do test and build at the same time because for build is building a Docker image. We don't actually use the Docker image to test. Whether we should or not is a different conversation. But roughly, this is like the end goal. And you want to compress this, right? That's like the major goal here, especially if you think about one of the big issues is like speed of tests and everything. So the first thing and the most important thing, and this is what I would encourage everybody to focus on, is get rid of humans out of anything you can. So automate everything, give a lot of access and visibility into systems. So and this is very true. At Sentry, anybody that has a Sentry email address can deploy code. If they have a Google account through our company, they can deploy code. So the office manager can go in right now, deploy to production. Now there's some checks that they likely won't mess up production because the only way they can deploy is if it's green, if it's been peer reviewed, et cetera. So they have to deploy a change that's valid. And these are the checks and balances. This is the automation we put behind it to keep that system in place. But otherwise, they do whatever they want, right? Now, we have an office in Austria, so we have a team there of engineers, and we have a team of engineers in San Francisco. There's certainly complexity when the engineers in Austria deploy code at like 5 p.m. their time, and everybody goes to sleep, and nobody's awake in San Francisco. But again, that's more of like the human problem that's harder to solve. We can find that out, or figure that out, rather. But this is super, super important. Like the whole idea of continuous deployment, which is the whole goal of a lot of this stuff, is to remove humans. And there's a lot of stuff you can automate that you're probably not doing today or you can make faster than what it is today. The biggest one of those is tests. So again, this is like, I think it was 2 talks ago. I missed most of the last talk, but they're talking about continuous integration. It's a very interesting topic. I'm happy to talk about that as well. It could be a whole talk. I think I've given like a 90-minute talk on continuous integration before. But I'm going to try to fit it in 2 slides. So optimizing your tests. So if the tests are slow, the way to fix it is not what we did at Dropbox. It's not to spin up 2,000 servers and run your tests on 150, or split it up among like 50 servers, right? Like, it doesn't scale. It's going to be 500 servers a year later or something. It's going to get more and more and more expensive. So the most common way, especially since most use SQL databases, is this. There's some really clever techniques to optimize around this. So at Discuss, we started with old Django, and Django has this built in now, which is great for everybody. It's a little bit harder if you use something like SQL Alchemy, but I do have these slides will be available somewhere. There's a link in one of our SQL Alchemy-based projects of how we do it. But if you use databases, what you can do is load all your fixture data into memory after you create the database one time, and then every time you run a test, you just reset a transaction. So it goes back to that clean state. You can't test transactions, but you don't really need to test if transactions are working in your database. You can just assume they are, right? And that actually shaves off. When I was at Discuss, I think we took the build from 40 minutes to 6 minutes by doing that. And this was on like a local machine, 6 minutes. So it was pretty good, just by that one change. It's baked into Django now if you use the standard test case. They also have the transaction test case if you really do need to test transactions, and you can really easily see the speed difference in those. It's drastic. So that's a big, easy win if you can implement it. Sometimes it's hard. Again, there's a code example up there if you use SQL Alchemy. That's specifically SQL Alchemy and Flask. I talked about like swapping out services. We have services inside of Sentry in our microlith. Like cache is a good example. Django does this in your development environment. Maybe you're using like the no-op or dummy cache, so it's not actually caching. That's a really good thing to do in tests as well, development and tests. So it's like keep production in production as much as you can. So for example, this might be changed today, but Sentry we used to develop against SQLite and Redis, and those were the only two requirements. We never ran SQLite in production. Nobody should have. It was always Postgres in production, Redis, 5 other database systems, right? But that was always enough. CI would test a little bit more of it. It would use Postgres instead of just SQLite, but it almost always worked because we had an abstraction that was tested and clean. And this is part of that, like, if you have this mock abstraction, these API contracts, you can actually make testing really easily. You only need a set of tests that test this specific database implementation. You don't need every test to run that specific database implementation. Databases are a little bit more tricky because they're flexible, but you get the idea. And the biggest one, and I'm not sure why more people don't do this, is mocking network calls. These are usually HTTP requests. There's a library I wrote quite a long time ago called Responses, works with requests. So if you're using requests, pull in this library, stop hitting third-party web services. If Twitter's API changes, that sucks, but you can test it a different way instead of hitting their API every single test case. Like, we do a ton of billing through Stripe. We never hit Stripe in our test cases. It's never been a problem. I can run our tests on a plane, which is really, really nice. I believe in this, or we have another library on GitHub somewhere. You can also shut down all HTTP requests, like actually block them, so every single one will error, which is really nice when you want to flesh out, like, why is the test suite hanging, if I'm on, like, bad Wi-Fi. So these are kind of like the core things. And I think profiling is really interesting. So how many of you actually have run something like cProfile on your test suites before? So I would expect it's like more than I thought. I thought it was going to be like one hand. I've only done this once in my life, and it was very interesting. This was at Dropbox when I'm like, why is this test suite so slow? It was like 3 hours long. And it's not what you'd expect. Usually it's like, oh, the database is slow, and so cProfile doesn't necessarily tell you a lot. In this case, they were using pylons, and it was a very old version of pylons, and regex was using like 30% of the CPU time. In this case, like, pylons had an unoptimized URL routing system where I don't remember if it was recompiling everything all the time, but it was really bad. And Dropbox said, NIH, not invented here, so much stuff that they couldn't actually upgrade pylons, so we actually had to go patch this problem, but we didn't know that without the cProfile. We're just like, I can't understand how these tests are so possibly slow. And this is a big one because you actually have to spend a lot of time on this. We had this there were 2 monolithic web services at Dropbox, and I could never fix one. Like, it was way too out of scope for me to accomplish this. Even getting these kind of database tests, which would have massively sped up their systems, I couldn't get them into place. There just wasn't enough time. So it's good to, like, be conscious of this and invest when you can. The other big thing is just test in production. Like, you can limit the consequences here. Bigger companies will set up something like a canary, like a lot of the major tech companies, canary might mean employees hit the service. So there's a new version that goes out, and it lives on employees only for the first week. So you'll flush out a bunch of bugs there. Then maybe when it goes to production is 1% of the audience, so it limits the impact of problems, which means you actually minimize all the risk, which means it's okay to fail. And this is actually like a core principle of Sentry. It's not that we want you to write code that's going to break in production, but it's that if it does break, you're going to know about it and you can limit the scope of that impact, right? Side note on this, feature flags are sort of another way you can manage some of this risk. There's not a lot of good open source libraries out there. We wrote one at Discuss a long time ago that's not really supported anymore. LaunchDarkly is like a paid, I think it's paid. I'm not 100%. It might be free and paid, but it's a service that you can do feature flags through. So check it out, write your own, it's not hard. There's one in Sentry for an example. Ownership. So, a lot of people, it's like, okay, well, we want to split it up among multiple repos to define ownership. Why? Like, I don't know, when did Google start writing code? Shortly after Google started writing code, they invented owners, which is a text file that's like plopped all over in their repositories that says, David Cramer owns this path of code, and Joe and Jane own this path of code. GitHub made this a little bit more popular when they launched code owner support, which is the same idea. So it lets you define ownership within a larger repository. Sentry now has the same concept of defining ownership. Like, I don't need to know about API errors. I don't need to know about any errors, but I definitely don't care about the API-specific errors. And so, like, this is actually how Sentry's deployed. They're not quite these host names, but our monolith actually runs 3 different services. We actually have those isolated on different clusters of web and worker servers. So they have different memory profiles, different CPU profiles. They're fully isolated. We can deploy them separately if we want, but it's the same code base that ships out there. It doesn't make the build time necessarily much faster in this case, but at least we control the availability and reliability of it. And then Docs, which is a completely different system, it's a different technology, that's deployed separately. And that's the only time we actually change services. So we have some Rust services that run off in some other land. We have our Doc side is built on Jekyll, which is a static site generator in Ruby. And that's how we ultimately approach this. And part of this is like creating like full ownership and accountability. So if you make sure everybody can deploy and they can get visibility into monitoring and metrics and everything else, you can put them on call. And personally, I think we should all be on call for our code rather than some dedicated team that has no idea what your code is doing. A lot of DevOps or SRE has sort of moved towards this over the years, which is like you have a core like systems team that will build the infrastructure, and then your team is like responsible fully for your service. Again, it doesn't require microservices to achieve this. It's very easy to implement. And has a huge, huge beneficial impact. And the last major thing is legacy systems. What do we do about those? We don't really have to do anything about legacy systems. If they're working, let them work. We don't have to change them. It's just making more effort for ourselves. We could be building something more interesting, something new, right? So just let them be. Again, I'm going to use a Dropbox analogy here because when I joined Dropbox, it was the worst code base I've ever seen in my life. It might still be the worst code base, but wow, is that company successful? So does it really matter? I don't know. All right, so in closing, there's a few things I'd love for you to take away from this, if nothing else. Remove humans is super important. Automate as much as possible. Enable people, don't block them, don't act as gatekeepers. There was an ops guy I used to work with who refused to give me access to production logs. I'm like, I'm not really sure what your job is if it's not helping me do my job and you're preventing me from doing my job. He didn't work there that much longer. Stop being an engineer. Academics are less important in a lot of what we do. Most of us are just building registration forms, very simple apps. Like we don't have to make a complex solution out of nothing. There are complexities, of course, but there's always like simpler solutions. Like look for the simpler solution. And this is a big deal for me. This is like, being self-taught. I'm not good at half of the theory or the mathematics behind a lot of what you might do in computer science, but I can glue things together very well. And I've always called it duct taping. And then measure time to ship. Like that's the metric that matters. Now, Agile sort of does this, but it's a little bit fuzzy, and quite frankly, I don't know how Agile fully works. But this idea of like time to ship, kind of like time to resolution of an issue, is like super, super important. And maybe that's just the time from when you push code up to GitHub to you actually getting into production. So for us, if somebody reviews my code instantly, like just clicks approve as soon as it's on GitHub, it still takes me I think a little more than an hour to get into production, which is not great. That's like a really bad thing at Sentry. Used to be 5 minutes, and now it's like, well, you have to run this build, and then when it merges, it has to run this other build, and it has to deploy, which is running this other build, and it has to deploy to hundreds of machines, which takes forever. So even we have a lot of work in that, right? It's like a never-ending cycle, which is why you often see bigger companies now developing people to what you call developer productivity, which is often like this kind of stuff. It was my role at Dropbox. And I think it's a really important concept, but it's expensive to have that at a small org. Cool. Well, thank you. I'm happy to answer questions about anything. I guess we got a few up here.
Okay, I think everybody can relate here to this talk. We have a few minutes, but I think like 5 is fine for answering a few questions. So Dave, whatever.
Cool.
You can pick some.
I'll just try to zoom through these. So how do you scale parts of your application? I think it's all different. Most of the time, it's just add more machines. We're actually pretty lean for what we are. Our server costs are very minimal for the amount of scale we have. In early October, we measured our event intake at 2 billion a day. And these are like large exceptions. Some of them are like 800 kilobytes in size, so they're pretty beefy. That system scaled very differently than, our docs scale just fine. But Sentry's like 100% like writes. It's very few reads. So it's very specific scaling characteristics for that one specific thing. And I think it's just, we monitor various metrics. We try to set SLAs. Nicola mentioned this. Like we have an internal SLA for when you send us an event, an error. I think we say we have to respond within 100 milliseconds, and we have to process it and make it available to you within 2 minutes. Those are our internal SLAs. So we actually set up alerting on those kinds of things. And if it breaches those, then we go dig into it deeper. But yeah, I think that's very specific. I'm happy if somebody wants to ask more pointed questions on the scaling of the application, the parts of it, I can answer that after this. How does your deploy process work with this architecture? We build a giant Docker container, ship it to a lot of servers, restart lots of services. Looks like it would 20 years ago, to be quite honest. Works well enough. We'll probably move to Kubernetes over time. Kubernetes is really, really complicated. I don't recommend anybody do it unless they're already doing it. But there's certainly a degree of when you have more services, and we probably have 10 at Sentry. Most of them are small and do nothing. Some of them I don't know if we can restart. I don't know how we deploy them anymore. But it is kind of building a standardized deploy process. And 5 years ago, I built that tool called Freight that you saw a screenshot of. It's on GitHub. It's not very good. But all it is like a UI for operating shell commands. So we click deploy, and it just runs some shell scripts, which effectively are shelling out to some bash scripts, which know how to deploy that specific application. So it varies, but that's our standardization. It's almost like a facade per that previous talk. When can we expect Sentry's APM product? We'll see. So the quick pitch on Sentry is we do error tracking now. We're going to do everything. But all we care about is applications. So what I want us to achieve is saying there's an issue in my application, and here's the code change that caused it. The issue might be an error. It might be a performance issue. It might be signups have gone to 0. We just want to correlate or causate when we can that to the code change. So we're going to launch some new stuff soon, but full APM is really hard. We have to write APM for every language, and we're at pretty serious scale now. So I don't know, give us 6 months, 9 months maybe. Why do you dislike MongoDB? So MongoDB used to be very, very bad, and people were like, this is the greatest database ever, except it lost all the data. So there's a project I started, and I probably shouldn't, as a CEO of a company, I probably shouldn't promote this, but there's a project I started on GitHub called MongoDB. It's under my name, which is just a running joke on all the problems MongoDB had. It had safe mode, which I think you had to turn on safe mode, otherwise you almost certainly lost data. And so I think it was just something that was over-marketed. I think it's a lot better these days. But also, everybody's not saying, yeah, let's use MongoDB these days, so it's win-win. I think it's one of those things that has trade-offs, just like every other database, not just NoSQL databases. And is there any NoSQL you like or use? Sentry, I think. So we use Redis for a lot of things. I don't think that quite counts, but we use Redis in a lot of unique and interesting ways. Very hard to scale. And then we use Riak. R-I-A-K. It's kind of dead technology, but it's a great key value store. Really, really phenomenal, easy to run. We don't use any of the other fancy features, but that was our first foray into any of this. Have been using that for 5 years, give or take. I don't think we use anything else. It's mostly all SQL. Oh, we are moving to ClickHouse, which I also don't recommend you run, but it's a Scuba-like system. Scuba is a technology from Facebook that's an append-only column store. It's very fast in memory search. For example, we can write SQL-like queries on ClickHouse, where we can search over hundreds of millions of rows in less than a second. I can actually answer how many errors have been seen within Sentry or across every project in Sentry, every single customer we have, in a few seconds, and that's billions and billions of errors. So it's a very fast, NoSQL database, even though it has a SQL layer. Why would you not use InfluxDB? We don't actually store time series in SQL. We store it in Redis. And it's super cheap for us in Redis. It's hard to scale, but we're deleting all that as well. All of that's going into ClickHouse. It's going to be real time. There's no caching, no time series database anymore in the future of Sentry. And I think that's the nature where we're getting to of hardware and software. Our apps have gotten slower, but hardware's gotten better. So at least we can now take advantage of better hardware by removing caching. So there's actually very little caching in Sentry anywhere. We have very fast response times for a lot of things. It's mostly in Python. But yeah, I've never actually used Influx personally, so I can't really comment on it. But I'm scared of technology, so. Do you think microservices architecture can't use single repo? I think it can. I think the idea of microservices, though, is the flawed one, of create a lot of little services, because the complexity of that is much more serious than the complexity of a large application running somewhere. There's certainly a trade-off in performance at some point, but I think if you just get rid of the micro part, I'm okay with it. Make them giant services that serve very important purposes. Find the reason it needs to be separate from the core code base versus finding a reason to make, to just do it for fun kind of thing. Name 3 advantages of using duct tape architecture over multiple service repos. Tooling. We can configure all of our linting, all of our other stuff in one repository. We don't have to set up some other scaffolding to configure it in 100 repositories. That is honestly, if nothing else, that's the reason. It's a really big deal, and it's really hard to solve.
Okay, we're kind of 5
Cool,
minutes
yeah.
over, but if you think you can answer one of them really fast, maybe?
I'll answer one, and then you can grab me after.
Okay.
When you have multiple services in the same repo, do you split it during build process? We ship the full code base right now, but splitting it's certainly an option to make it faster. I don't know if we'll do that in the future. Google, Facebook, et cetera, I think do that. Dropbox does now. Makes sense, but it's another complexity that we'd rather avoid unless we have to. So, cool.
Okay. All right. Thank you very much, Dave.
I guess my experience with PyCon Balkan has been great. I actually didn't know where Serbia was on a map before 2 days ago. It's been really cool. The city's beautiful. The conference has been good. It's been like really, really good, honestly. I've been to a lot of like regional conferences, especially in Europe, and like the venue's great, the hotel's great, the food's been good. The talks have been interesting. I've only been able to see a few so far, but it's been really fun. Like, why did I come? Honestly, I thought it was a really interesting opportunity. I really like engaging with people. I don't do it a lot anymore. I sort of take this test every single year of like, should I start speaking and engaging more? It's always like a stressful thing. So I'm like, okay, there's an opportunity. You know, I'll go meet some new people, meet some old friends as well, give a technical talk. That was really it for me. Like, just sort of the opportunity to meet new groups of people.